Okay, this is the third video in this series devoted to variations on the Hummer principle. So as you can see, I have various cards of different values, suits, and colors. We'll go ahead and gather these up. And so what I need you to do is help me mix these. We want to mix these beyond the knowledge of anyone, okay? In fact, we can kind of begin to mix them. So I'll just do a left-right. Okay, how would you like these stacked? Left on right? Okay, very good. Why don't we go ahead and also follow that up with a Klondike. That's a very good shuffle because it's taking cards that are kind of far away from each other and bringing them close together on the outer ends there. You'd like to do another Klondike? Okay, that's fine. Okay, so we'll do another Klondike. Can't hurt because it's just going to mix things further. I don't know if you've heard of the Mange shuffle. It's kind of a fun one. This is where you can go like over, under, over, under, over, under, over, under, over, under, over, under, over. Kind of an interesting one. We can follow that up with a Charlier. Okay, so what we're going to do is I'm going to kind of mix the cards in hand, and then we'll also mix them on the table. So right here, should I leave these cards as is or flip them? Flip them? Okay. And then we'll just randomly cut. In fact, we'll flip odd numbers of cards, okay? And one's an odd number, so would you like to flip this one? You would? Okay, very good. Okay, what would you like to flip? 1, 3, or 5 cards? 3 again? Okay. Random cut. What about here? 3 again? Okay, what about over here? 5? 1, 2, 3, 4, 5. Okay, we're kind of putting things back to where they were, it seems like. What do you want to do here? You want to do 5 as well? Okay. Okay, you want to do just 1? Okay, that's good. You want to do 7? Well, 7's an odd number, so 1, 2, 3, 4, 5, 6, 7. Flip. Okay, why don't we just do one more? Flip 5? Okay, so there's 5. I'll flip it. Why don't we also do it on the table? So I'm going to push these off. Maybe we'll do 3 at first. So should I leave or flip? It's your choice. Flip. Okay. Leave. Flip. Flip. Okay. Very good. What a mess. Okay. What about here? Should I do maybe 5? Okay. Leave or flip? Flip. Maybe we'll do 3 now. Leave. Okay, and then maybe we'll do 3 again, flip. And what about these 3? Flip. Okay, wow, very, very good. Now, we can actually do even numbers as well. So like right here, I have 2 cards, so I could actually put those down. You want those also flip. That's just fine. Okay, just leave as is. Okay, flip, leave. Okay, very, very good. Okay, well, do you feel like these are sufficiently mixed face up, face down? You do. Okay, well, let's go ahead. We're going to divide these cards into 2 packets, okay? And we're going to do it kind of in a fun way. What I'm going to do is I'm going to pull off that top card. Then we're going to a Klondike shuffle. Klondike shuffle has gotten a lot of work in this particular presentation here. Lots of work for that shuffle, okay? Well, let's just see how we did. We kind of separated these, and let me see if I can get a feel for what we may have done or may not have done. Okay, let me see. Concentrate. Ooh, very, very interesting. We've done something that I'm not sure I've ever presented on my channel before, and I think that actually is an accurate statement. Somehow you have separated the Fibonacci numbers between 1 and 13 from the non-Fibonacci numbers. I don't know how in the world you could do that. What kind of mathematical intuition do you have? Okay, well, do you remember what the Fibonacci numbers are? Very important sequence. Very interesting sequence. Well, it begins with a 1. In fact, the sequence begins 1, 1, which is kind of funny. And then the next element in the sequence is found by adding the previous 2. So 1 plus 1 is 2, okay? The next element in the sequence would be a 1 plus a 2, which is a 3. The next one would be 2 plus 3 is 5. The next one, if we add the previous 2, is 3 and 5 is 8. And then if we add 5 and 8, we get 13. So those are the Fibonacci numbers between 1 and 13. So it's 1, 2, 3, 5, 8, and a king in our case, right? A king will be a 13. Well, there's one Fibonacci number right there. It's 13. Oh, that's a 5. That's a Fibonacci number. Of course, an ace is. So very good. Sorry, we're going off the camera there. Let me move these up here. We don't know what those are yet, but a 2, yes, 2 certainly is a Fibonacci number. Okay. What about this one? Oh, an 8 is. Yeah, in fact, we can kind of put them in order if you'd like. What about this one? Yeah, well, technically, let me just rearrange these here. Technically, there are 2 1s involved in creating that sequence. We're just hoping that this is a 3. Oh, it is indeed. We got all of the Fibonacci numbers between 1 and 13. How is that possible? Well, to be 100% accurate in what I sense here, none of these better be Fibonacci numbers, right? Otherwise, we haven't separated them. Well, 10 isn't, 7 isn't, 4 isn't. What about this one here? No, 11, Jackson 11, that's not a Fibonacci number. 6 isn't as well. 9 is not. And what about the last one? We hope for a non-Fibonacci number, and it's a 12. And that indeed is not a Fibonacci number. Okay, so I'm going to just quickly show you the mechanics of this little presentation. And then in the next video, we're going to give you a full tutorial for all 3 presentations in this series so far. Okay, so what you do if you want to perform this right away is go ahead and just gather up Fibonacci numbers, Fibonacci cards, I guess we can call them, between 1 and 13. So these are fine. So a couple of aces, a 2, 3, 5, 8, and a king. That would be 1/2. There you go. And then just randomly select 7 non-Fibonacci card values. Okay, and that will be your second packet. Okay. And then what we need to do, which is what we've done in previous presentations in this series, is we need to have these in an alternating relationship, left, right, left, right. And a slick way of doing that is to just stack those and take advantage of the properties of the Klondike shuffle, because that puts the top and bottom in a alternating relationship relative to each other. So now it's alternating Fibonacci number, non-Fibonacci number, and so forth, okay? So this is the kind of packet I began with. So when we started this, I spread out the cards, and this isn't the exact ordering, of course, and had you look at those, and so right now they're alternating Fibonacci, non-Fibonacci numbers throughout. Okay, and then from there, because it is cyclic, it's an alternating packet, you can perform random cuts, and that won't hurt that characteristic. A better shuffle is the Charlier shuffle. This is the top to bottom, bottom to top shuffle. And it really gives the impression of just mixing the cards thoroughly, when in fact all of the movement of the cards that you just saw is equivalent to just cutting the packet at some location, which is absolutely amazing. So I'll put a link to the Charlier shuffle in the description below if you want to watch that. Okay, and then I think we did some initial mixing while we did the Charlier shuffle. I think we did this left-right kind of mixing of things. Technically, this separates them again, a random stack, but then we followed it with the Klondike, okay? So that puts them back. If you know what's going on, you realize that we're kind of going round and round in a circle here. So now we're back to an alternating packet, okay? But most people do not know that the left-right shuffle paired with the Klondike shuffle has that net property on a packet of cards. Okay, so we're kind of back to the sort of packet we need, even though the ordering of the cards will be different. The cards are being moved around a little bit. I think I even did another Klondike. Do you remember that? So you can actually do a second Klondike. Now this is genuinely messing things up. Okay, our alternating packet is destroyed. It's gone. Okay, but what we do is we follow that up with the mathematical inverse of the Klondike shuffle, which is the Monge shuffle. Okay, So you can, in this case, you can do either an over-under or an under-over. Either one works just fine. Okay, so it will undo the effect of the Klondike. Now, depending on whether you do an over-under or an under-over, one of those returns the packet to exactly the way it was before the Klondike was performed, and the other one reverses the order of all of the cards from what they were. Well, reversing an alternating packet doesn't change the fact that it's alternating, so it won't harm anything. So you can do either an over-under or an under-over, okay? And then from there, we did some in hand, right? I said, okay, we'll randomly flip those, okay? And then we'll do a random cut, flip 3, random cut, maybe flip 5 this time. We can flip any odd number of cards. You can even flip just one card if you'd like. Random cut. Okay, so this is reminiscent of the traditional Hummer principle or Hummer shuffle. There, you're only working with even packets. That's the important difference. So what we're doing here is fundamentally different. It really, really is. You would never flip over an odd number of cards within a Hummer performance for the simple reason it will destroy the packet in a way that the Hummer principle will no longer apply, and it won't lead you to the wonderful ending properties for that packet. Okay, so this is, very, very different what we're doing, and we'll explain all of the mathematics in this next video coming up. And then we did it to the table as well. I said leave or flip. Maybe you say flip, leave, and then flip. Now you can do 5 at a time if you like. Here's 5 of them. Maybe flip those. Okay. I also introduced the fact that you can, which is amazing, you can actually deal with an even number of cards. Now the only thing you have to be aware of is if you choose to do that, or if at the very end when you're doing this, you're left with like 2 cards or 4 cards, and you want to leave them that way as 2 cards or 4 cards, when you set that little packet down, it must be flipped from its current orientation. It has to be flipped. If you do that, you're safe, okay? But if you don't want to introduce that level of complexity, just work with odd numbers of cards, 1, 3, 5, and so forth. Okay, and then from there, I introduced a new way of separating an alternating packet. So believe it or not, this is still alternating. I mean, it's absolutely amazing. So this is still alternating Fibonacci numbers, non-Fibonacci numbers. So there's a non-Fibonacci, there's a Fibonacci, here's a non, there's a Fibonacci, and so forth. So we checked all these. In fact, we'll find out in a minute if we made a mistake because it won't work in the end. But we're going to now pull apart the even position cards and the odd position cards. We're going to separate this into 2. And the way I showed you, which I've never seen before, it's kind of fun actually, is what you do is you just pull off, you don't make a big deal, you just do it. You pull off the top card as a single card. And now what will happen is the even position cards in this original packet, which would begin here, this is the second card down, they will now be in a mirrored relationship. So this card here has position 2. This one has position 14. So what's going to happen is you're going to be pulling off even position cards here, then odd position cards, even position cards, odd position cards, even, odd, even position cards. Okay, not even value, position in that packet. Okay, so that's just a more sophisticated way of separating an alternating packet into 2 halves where you pull apart that alternating structure. Okay, and so if we haven't made a mistake, these should all now be Fibonacci values, cards, and these should be non, okay? And I just hope that we've done it, and if we haven't, it's because of some silly mistake, but just check this one. Oh, we did it, okay. So these are all Fibonacci, and then of course these are non, okay, as you can check. Okay, well, very good. Well, if you're interested in understanding the whys of all of this and understanding how it relates to the traditional Hummer principle and why it is indeed genuinely different and new, watch for the next video, the final video actually in this series that's dealing with variations on the Hummer principle. So thank you for watching, and I look forward to having you join me in the next and final video in this series. So thank you again.